Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus bin Rahmat. I'm from National Institute of Aviation Technology. Okay, I'm going to teach you about physics and aerodynamic topic, optic light and sound wave. Okay, let's restart our slide. Okay, in chapter 11, optics, we will learn about properties of light like emission, color, law of reflection and refraction, light wave. Nature of light. Light waves are a part of a group of electromagnetic wave or radiation. Light wave or radiation include X-ray, ultra-rays, ultraviolet, infrared rays, and radio wave. Light waves have a certain properties which are common. These are: they travel through space at the speed of light. They obey the equation V equal F lambda. They carry energy from one plane to another, and on absorption cause a rise in temperature of the observing body. Light diffusion. Within the light, there are 6 colors that can readily identify: red, orange, yellow, green, blue, and violet, with indigo being difficult to distinguish. Sir Isaac Newton was the first person to explain this band of colors, known as spectrum, using glass prism. When light passes from one medium to another, it is refracted. When white light passes through a prism, it is refracted twice. Red light refracted the least and violet light refracted the most. The expression white light in this manner into the color of the spectrum, the color of the spectrum is called diffusion. Reflection. Reflection is the change in direction of a reflection when it bounces off a boundary. There are two laws of reflection. The angle of incident I is equal to the angle of reflection R, and the reflected ray lie in the same plane as incident ray, and the normal at the point of incident. Okay, this law of reflection apply equally to this law of reflection. That curved and flat surface. Curved mirror are of two types: concave and convex. Concave and convex mirror. A concave mirror is a surface that shape towards the middle and arcs the middle and away from the observer. A convex surface is a surface the center is shaped out towards the shape out towards the observer. It is in opposite direction to a concave surface. Refraction. A change direction of the light ray occurs when light ray move from one medium to another. Example, air to water. This is called reflection. You can see from my slide, incident ray to reflected ray. Observation on light reflection. The ray of light is bent towards to the normal when it enters an optically dense medium at an angle. The ray of light is bent away from the normal as it enters the less the medium. It moves from the glass to air. Light refractive index. This is the formula. N is the index of refraction, equal to C, velocity of light in vacuum, over V, velocity of light in the medium. Okay, Snell's law. The formula of Snell's law is N equal to sin I over sin R. N is refractive index, I is angle of incident, and R is angle of refraction. Critical angle. Okay, you can see from my slide, and this is total internal reflection. You can read it. The refractive index. Lens. There are two basic lens: convex lens, or also known as converging lens. The other one is concave lens, or known as diverging lens. The distance between the focal point and the top distance and the optical center is known as focal length and is given the symbol F. Okay, power of lens P equal to 1 over F, where the image is position and its nature, real or virtual, can be found, or virtual. can be found by using formula, the Lens formula. Okay, this is the Lens formula. 1 over f equal to 1 over u plus 1 over v. Okay, u is the distance of object from the lens, v is distance of image from the lens, f is the focal length of the lens. Since this formula may be used for both convex and concave lens involving both real and virtual image, a sign rule, positive or sign rule, must be applied. Light. Electromagnetic wave. Electromagnetic wave light consists of coupled electric and magnetic fields that vary periodically as they move through space. These fields are perpendicular to each other and the direction of the wave. Hence, the waves are transverse. It requires no medium to travel and can transport energy. Okay, radio wave, light wave, X radio wave, light wave, gamma rays, and are example of electromagnetic wave. Electromagnetic wave. They differ only in frequency, and the color sensation depends on the frequency, with the red being lowest visible frequency and violet is the highest. In the free space, all metric waves have the velocity. Light is c equal to 3 times 108 meter per second, equal to 186,000 miles per second. Characteristic of light. Apparent depth. An object submerged in water appears closer to the surface because the light leaving the surface bends away from the normal as it leaves. The object also seems shallower than it actually is. The ratio is apparent depth and true depth is equal to reflection index of liquid and refraction index of air. Lens. There are two basic types of lens: converging and diverging lens. Properties of length. Focal length. The focal length of a thin lens given lensmaker equation 1 over f equal to the ends 1 over f equal to n minus 1, 1 per r1 plus 1 per r2. Okay, you can read from my slide. Concave mirror. Concave mirror. The flattening surface has the shape inside of a sphere. It converges parallel beam of light to a focal point. F in front of the mirror light pass through the focal line. That's called real. Okay, this is convex mirror. Okay, convex mirror. The reflecting surface has the shape of the outside of a sphere. It diverges parallel beam of light so that the reflected rays appear to be from focal point. Okay, the formula F equal to negative R over 2, where R is the radius of curvature of the mirror. Properties of lens. Okay, this is lens equation. This is the formula. Okay, chapter 10, wave motion. Microwave energy can travel in form of matter, by particle, and by wave. A wave is a disturbance of a medium which transport energy through the medium without permanently transporting matter. In a wave, particles of the medium are temporarily displaced and then return to their original position. The two most common forms of microwave are transverse and longitudinal wave. Transverse wave. For transverse wave, the displacement in the medium perpendicular direction of propagation of the wave. A ripple on a pond, a wave on a string are easily visualized. Transverse wave. Transverse wave cannot propagate in a gas or liquid because there is no mechanism for driving motion perpendicular to the propagation of the wave. Transverse wave. Okay, you can see this picture in my slide. This is transverse wave. Okay, longitudinal wave. In a longitudinal wave, the particle displacement is parallel to the direction of wave propagation. The particles do not move down the tube with the wave, they simply oscillate back and forth. They are in the equilibrium. The wave is seen in the motion compressed region, which move from left to right. Okay, this is the longitudinal wave. Wavelength compression, and this is refraction. Water wave. Water wave are example of wave that involve a combination of both longitudinal and transverse motion. As a travel through water, the particles clockwise circle. The radius of the circle decrease as the depth into the water increase. I have identified two particles in yellow to show that each particle in it travels in a clockwise as the wave passes. Wave characteristic wavelength, the distance between two crests, frequency, the number of wave crash pass one every second. If one crash goes by you every second, then you will say that the frequency 1 second per second, 1 hertz. Amplitude, the height of the wave crest above undistributed velocity. The speed and direction. Okay, the speed and direction that the wave crest itself is moving. Okay, the relationship between wavelength, frequency, and velocity. There are simple relationship between the wavelength, frequency, and velocity. If you know any two of them, then you can compute the third using formula V equal to lambda times time. Okay, interferent wave, interferent or superposition occurs at the point where two or more wave meets. Okay, there are two types of common interference: constructive interference and destructive interference. This is where two waves having different amplitude and superposition to the wave produced as increases seven away from the amplitude. Destructive interference is where two waves having different amplitude. The second wave is produced out of phase first. When combined, the effect reduces amplitude of the first wave. Check the then sound. Sound C frequency. Okay. Sound intensity determined by amplitude of the sound wave. The higher the amplitude, the higher the sound measured. Decibels ratio from one to another. 1 dB smallest change. Intensity the human can hear detect. Frequency the number of vibration completed per second. 1 F equal to 1 over T, where T time is second in hertz. Higher the sound, higher the pitch. Okay, sound of propagation, transmission and reception. Sound source, medium detector. Range of human can hear that 20 to 20,000 hertz. Doppler effect. Okay, the apparent rise in the pitch or frequency of sound source approach the hearer and the decrease in pitch as the source move away. The Doppler effect. Sound vibration cause wave radiate from their source at the speed of sound. Aircraft move less speed of sound. The sound move ahead of the aircraft. Aircraft flies at the speed of sound produce shock wave. Speed of sound, the speed at which the mechanical vibration of sound travel in elastic medium varies with temperature and altitude. Mesh number, the ratio the plane to the speeds on the same condition. Mesh number equal to the speed of light, speed of the aircraft per speed of sound. Resonance, the two natural frequency given vibrate naturally or without external force. Two objects have similar frequency. If one vibrate, the other one can move. This destructive force. Resonance is a picture of resonance you can see from my slide. Okay, a wave is in general is that wave move through a medium. Okay, from this wave. Okay, you can read from my slide. Wave property. The period T wave is the time required for one complete wave to pass given point, and thus frequency F equal to 1 over T, which its unit hertz cycle. Okay, the wavelength. The wavelength lambda is the distance between adjacent wave crests. Okay, wavelength velocity equal to frequency time wavelength. Lambda V equal F lambda. Okay, sounds. Some waves are longitudinal waves that consist of varying pressure. They can travel through solid, liquid, and gas. Okay. The speed of sound is constant for a given material under a given condition. Okay. This is a type of longitudinal wave. And this is transverse wave, amplitude, and this is period. Sound travel at different speed in different material. Air is a pure conductor. Water is better and solid is the best, depends of the arrangement. Okay, next, Doppler effect. Okay, Doppler effect. When there's relative motion between a source of wave and observer, the apparent frequency of the wave is different from their frequency. This change of frequency called the Doppler effect. Okay, Doppler effect. In the case of sound wave, the frequency f is given by f equal to fs v times v plus vl divided by v minus vs, where vl sound velocity of the listener and vs sound velocity of the source. Okay, that's all from me. Thanks for watching. Hope you enjoy it. Okay, that's all. Thank you. Goodbye.